Start, yeah? Okay, can you see the screen right now?
Yes, doctor.
Okay. So, Assalamualaikum warahmatullahi wabarakatuh and good morning. So, we are here today to continue analysis of indeterminate structure. This time, we are going to actually derive the compatibility equation. We will analyze indeterminate beam to the second degree of indeterminacy. Okay, so we have in the system, in the figure, an indeterminate beam. There are 5 unknown reaction. There are 5 unknown reaction fixed at A, roller at B and C. So there are 5. 1, 2, 3, 4, and 5. Okay, so remember, we cannot calculate 5 unknown reaction because we can only calculate 3 using equilibrium equation. Okay, we cannot use equilibrium equation only. So what we need to do is we have to have another equation to solve for the redundant. Okay, now we have 5 unknown reaction. We have 5 unknown reaction, and only three can be solved using equilibrium equation, and 2 we will determine by using compatibility equation. So by using this diagram, this beam, we are going to derive the compatibility equation because redundant will be determined using compatibility equation. Okay, so we consider this beam. Okay, calculate reaction at support A. Okay, when we have indeterminate structure beam, either it is beam or frame or truss. Okay, so first thing to do is we have to calculate degree of indeterminacy. We have to calculate the degree of indeterminacy. So degree of indeterminacy for this beam we will get 5. We will get 2. We will get 2. It is 5 representing 5 unknown reaction for the whole. Okay, for the beam, in total there are 5 unknown reaction comes from support, and only three can be determined using equilibrium equation. Only 3 can be determined using equilibrium equation. So we have 2 redundant. We have 2 redundant. And these 2 will be determined using compatibility equation. Using compatibility equation. Will be determined using compatibility equation. This is redundant. Number of redundant in the system will be determined by finding the difference between number of unknown reaction and 3. Okay, so what we need to do is we have to select a number of support reaction equal to degree of indeterminacy. The choice of the redundant will vary. Will vary means we can have. Okay, if when we analyze beam with one redundant, we can have two redundant option. We can have cantilever beam. Cantilever beam. Recall back to what we have learned previously. Yeah, recall back to what we have learned previously. This one, A and B. Okay, for one redundant like this, it is 4 minus 3. It is 4 minus 3. So we will have what we call as possible primary structure, because we can have uh, the primary structure, the primary beam as cantilever beam, or we can have the primary structure as simply supported beam. And if we choose cantilever beam, for the primary beam, we actually remove By, and when we have a simply supported beam as the primary beam, the redundant that we remove is MA. Okay, so these two diagram, this diagram, as well as this diagram, both are determinate. Okay, this is called as possible primary structure. These two is called as possible primary structure or possible primary beam, possible primary structure. We have two redundant option, whether we want to remove By and have cantilever beam as simply supported beam and redundant beam, and we can also remove we can have simply supported beam whenever we remove MA as the redundant. Okay, now when we look at this beam, now we have 5 unknown reaction. If one redundant, we have 2 possible primary structure. 2 redundant, we will have 3 possible primary structure. We can have 3 set of solution. One redundant, we have 2 set of solution, and and actually we only have to choose one solution, one set. Okay, and for 2 redundant, we will have 3 possible primary structure. We will have 3 possible primary structure, and we have 3 set of solution. So we can choose either one to analyze. Okay, to analyze, to determine redundant as well as remaining reaction. Okay, so this is the meaning of this statement will vary. The choice of redundant will vary since any of the unknown reaction can be utilized as redundant. Not all, uh, but after removing redundant, we have to make sure that we get either simply supported beam or cantilever beam. For example, okay, we have now like this fixed roller, fixed roller. We have UDL here. So we have 1, 2, 3, 4, and 5. This is the actual beam. This is the actual beam. So set number one is when we want to have cantilever beam, means that we remove By and Cy. So if this is the primary beam, we remove By and Cy. So this will be set number 1. Okay, set number 1, and this is the primary. This is the primary beam. Okay, this is set number 1. We can have simply supported beam. We can have simply supported beam as the primary beam. So what happened is, when we have simply supported beam, we have pin here and we have roller here. Okay, A, B, C, A, B, C. So if this, okay, set number 2, if the second diagram is the primary beam, it is simply supported beam. This is primary beam. Okay, there are two reaction we remove from this. Okay, the 2 reaction that we remove are out of 5. When we want to have simply supported beam. So by looking at this diagram, okay, tell me the 2 reaction, the 2 redundant that we remove from the system. Who can tell me?
MA.
Yes, we remove MA and we remove?
BY.
Yes, BY. Okay, that is set number 2. Set number 2. Okay, another set is set number 3. Set number 3 is when we have this as the primary beam A, B, C. If this is the primary beam, if this is primary beam, what are the two redundant that we remove from the system? We remove?
CY.
We remove CY, correct? Lagi satu?
MA.
MA. Okay? So we have now 3 set of solution, and we can choose any set that we want to continue. Okay, so we have set number 1 where we have cantilever beam as the primary beam. So we have BY and CY as the redundant. Okay, set number 2, we have simply supported beam A at pin. A at pin lah. Pin at A. Okay, and roller at C. Roller at C whenever we remove MA and BY. Whenever we have MA and BY. And okay, we can have set number 3. Set number 3, we remain pin at A, we remain roller at B. So in this case, it is also determinate beam, because when we check for degree of indeterminacy after removing redundant, we get 0. Okay, and we remove CY and MA. Okay, so we have 3 set of solution. We have 3 set of solution. So all these 3 diagram, okay, this diagram, and this diagram, okay, these 3 diagram are called as possible primary structure. Possible primary structure. The term representing these 3 diagram is called as possible primary structure. This is the term that we use, because sometimes in exam there is a question asking you draw possible primary structure. Draw possible primary structure. So you should okay give the 3 possible primary beam. These 3. Okay. 1, 2, 3. 3 possible primary structure. Okay, do you have questions so far? Do you have question?
Yo, okay. Tiada.
Okay, eh? So far okay.
So far okay.
Okay. Sekejap nak buka. Yeah. Okay, so these 3 possible primary structure. Okay, so we move back to this explanation. Okay. So what we need to do next is, after we select redundant, now we know that we can have 3 possible 3 set. We can have 3 possible primary structure, And for each primary structure, there are set of redundant. Okay, after that, we have to remove the redundant from the system. So because redundant is the problem, we need to determine the redundant first. Because without redundant value, we cannot determine three remaining reaction. So we have to determine the redundant. So when we want to determine redundant, what we need to do is we have to remove redundant, and we will analyze all the system. Okay, we have primary system, we have redundant system. Now we have two redundant system. We have redundant 1, we have redundant 2. We have redundant 1 and we have redundant 2. What we need to do now is to remove restraint at the redundant. Okay, remove. Okay, support restraint. Remove restraint because the redundant is the restraint corresponding to selected redundant from indeterminate structure to obtain primary determinate structure, primary beam. Okay, this determinate system must be stable and it must be determinate. Okay, the system must be stable and determinate. Okay, after that is we will write the compatibility equation. Write compatibility equation because like what we have done previously, after we understand about the compatibility equation, which is actually come from displacement, we look at the displacement occur at redundant position from each system. We are actually referring to the principle of superposition. In principle of superposition, we have the general equation. This is principle of superposition. We have general equation that we write from this principle. It is actual beam equal to primary beam equal to plus redundant number 1, redundant by applied, plus redundant number 2, redundant cy applied. Okay, redundant number 1, redundant number 2, redundant number 1, redundant number 2. Okay, we put redundant by applied and redundant cy applied. uh, by and cy we apply as an applied load into the cantilever beam. In this case, this is cantilever beam. Okay, and so all will be cantilever beam. Okay, by also cantilever beam. Cy also redundant by applied also cantilever beam. Redundant cy applied also cantilever beam. All these three must have same type of beam. Primary beam, redundant by applied, and redundant cy applied. All these three must have same type of beam. Okay, so the difference is only due to loading, because in primary beam, it is a determinate beam subjected to external loading. Redundant by applied, redundant number 1, it is a cantilever beam subjected to by. And in redundant cy applied, redundant number 3, it is a cantilever beam subjected to cy, a unit value of cy, a unit value of by. Okay, so we have to sketch deflected shape in order to see what is actually occur at both redundant position. So we have to sketch deflected shape. Okay, deflected shape of all system, in actual system, in primary system, in redundant number 1 and redundant number 2. Okay, so this is actual beam. In actual beam, when we draw the deflected shape due to all support, so we have like this. Okay, we have deflected shape like this. Okay, so by looking at the support, remember whenever R1 is BY, means located at B, R2 is CY, located at C. This one is C position, this one is B position. So we need to refer to the redundant position. Redundant position. Look at the displacement occur at redundant position. Remember that BY and CY both are P, and P we have to find the delta. If moment, we have to find theta. If P, we have to find delta. So now BY and CY are both P. Okay, so we have to look at the delta. We have to look at the delta occur at position B and at position C. Okay, so we have to mark delta B in actual beam. That is equal to 0 because of the support, and we have to mark delta C, which is also equal to 0 because of the support. Okay, delta B is equal to 0, delta C is equal to 0. Because we have to look at the redundant position. We have two redundant position, B and at C. Okay, now this is actual beam. This is equal to primary beam. Primary beam. In primary beam, okay, it is now cantilever beam subjected to 10 kilonewton per meter. It is external loading. We have to remain all external loading in primary beam. Okay, remember that we have to mark the delta at redundant position, and we have two redundant position. One is located at B and another one is located at C. Okay, two redundant position at B and at C. We have to mark the delta at B, delta at C in primary beam. In primary beam. So we label this delta as delta B naught and delta C naught. Delta B naught and delta C naught. Same with previous. Delta B naught means delta at position B. Delta at position B for primary beam. Symbol naught means we know that this is actually displacement in primary beam. We have delta B naught, we have delta C naught. Delta B naught means delta we measure at position B. Delta C naught means that we measure the delta at position C, and both are located in primary beam because we identify from naught symbol, B naught, C naught. Okay, we have to mark this two delta. Okay, and due to principle of superposition, actual beam is equal to primary beam plus redundant beam. And this time we have two redundant. One is called as redundant BY applied. Another one is called as redundant CY applied. So for redundant BY applied, okay, it is a cantilever beam subjected to a unit value. A unit value of BY. Okay, that is why the importance of putting the right label. BY here, BY here. Okay, we know that this is a system. This is a redundant system. Redundant BY applied means 1 times BY. Okay, 1 times BY. So we have to put a unit value at point B. We have to put a unit value at point B because it is 1 times BY. Okay, a unit value at point B. Okay, now due to a unit value, okay, the beam deflect. Okay, the beam deflect, and we have to mark the delta at 2 position. We have to mark the delta at 2 position, at position B and at position C. And the delta due to a unit value is called as F. Both are F. Okay, the first notation is for the position ni, position B ni. Okay, position B. Okay, yang ni position C jadi FC. Okay. Dekat B sebab position dia position B. So it is FB. At C, because the position is C, it is FC. That is for the first notation. For the second notation refers to type of beam. It is redundant BY applied. So we will put B as the label. So B and B. So we have FBB at position B. We have FCB at position C. The first notation is for the position. Okay, we have FBB and FCB. And remember, F cannot stand alone. In the equation later on, we have to times with BY, times with redundant. Okay, this diagram, do you have any question? You have question?
Tak ada.
Okay, so now we move to redundant CY applied. For redundant CY applied means we have cantilever beam subjected to a unit value of CY. A unit value of CY. So what happened? The beam deflect. Okay, the beam deflect. And we have to mark the delta. We have to mark the delta occur at 2 position. One is at position B, 2 is at position C. Okay, both we label as F. Okay, and the first notation is for the position. So at B, it is FB. At C, it is FC. Second notation for type of beam, it is redundant CY applied. So we use C as the label. So this is FC, this one, FC, and this is C. So in redundant CY applied, at position B, we have FBC, and at position C, we have FCC. And remember, these two, we must times with CY. We have to time with CY because F in the compatibility equation cannot stand alone because it comes from a unit value. F is occur due to a unit value of CY. It cannot be stand alone. In the equation, we must pair with CY, with the redundant. Okay, now we will continue to write the compatibility equation. So we will have two compatibility equation because we have two redundant, two position. So we have two equation. Okay, we will have one equation at position redundant number 1. We have second equation at position redundant number 2. Okay, the compatibility equation can be written according to deflection in this case. Okay, at figure 2.3 is actual beam. Actual beam delta is equal to 0 because of the support. Delta is equal to 0 because of the support. Okay, then kita tengok diagram kat sebelah ni. Nanti definition ni you baca, this is just the physical meaning. The physical meaning is just the same like what I mentioned previously. The definition. Okay, we just need to look at this. Okay, we have actual beam. Okay, and in actual beam, we have this. Okay, this is actual beam, UDL here. So 1, 2, 3, 4, 4, AX, and moment. So this is MA, AY, sorry, AX, AX, AY, BY, CY. Okay, so we label as A, B, and C. Okay, so this is W. Okay, this is W. So this is equal to, primary beam, we remove BY, we remove CY. So this is primary beam. Okay, this is primary beam. And we have another two diagram. Okay, this is a unit value of BY and remove W. And another one is redundant. Okay, redundant CY applied times CY. Okay, there's no external loading. This is redundant CY applied, so a unit value of CY. A unit value of CY. Okay, so we have four system. We have four system. This. Okay, so yang ni actual beam equal to primary beam plus plus redundant BY applied, plus redundant CY applied. Okay, so we have to previously we mark the deflected shape. Okay, we draw deflected shape. Okay, so we mark the delta. We mark the delta. Okay, of course, delta. Okay, this delta is equal to 0. This delta is equal to 0. Okay, and we have delta B naught, delta C naught, and we have FBB, FCB, and we have FBC and FCC. So by looking at these four diagrams, by looking at these 4 diagrams, remember that we have two redundant position. Position number 1, position at B. Number 2, the position is at C. So we will actually write the equation. Okay, there are two equations. We will write at position 1 and position 2. Okay, so we will have two equation. We will have two equation. If we write the equation from the principle of superposition, we will get, okay, remember, because we know that this is equal to 0, because this is equal to 0, this is equal to 0, delta B is equal to 0, delta C is equal to 0. So always write the compatibility equation start from primary system, so that we will get equation which is equal to 0. Okay, start with primary beam. Okay, just focus on the first position, means position B in actual beam, position B in primary beam, position B in redundant BY applied, position, okay, this position B in redundant CY applied. Tengok sebaris ni. Tengok sebaris. Tengok sebaris, write the first equation. Tengok sebaris, write the first equation. Okay. Do you get that? Can you write the first equation from this line, from the first line? You nampak kan yang 10 duk jalan tu, you nampak kan? The first equation, can you write the first equation start from delta B naught? Start from delta B naught, we plus with apa? Okay, can you write the first equation? Can you write the first equation? The first equation, what is the first equation?
Delta B naught
Yes, delta B naught. Lepas tu?
plus FBB
Plus FBB.
multiplied by BY
Multiply by BY, correct. Lagi?
plus FBC multiplied by
Plus
CY.
FBC multiply by CY. That is the first equation. Okay, and that is correct. Okay, what about equation number 2? Equation number 2 starts with delta C naught. Start with delta C naught. Apa dia equation dia?
Delta C naught
Delta C naught. Delta C
plus
naught plus
FCB
FCB.
plus FCC.
Remember, F cannot stand alone. We must multiply by redundant. So don't forget. Okay, it is FCB times BY plus FCC times
TY.
CY. F cannot stand alone. Okay, in the compatibility equation, we must pair with redundant. FBB times BY, FCB times BY, or FBC times CY, FCC times CY. Then only the equation will correct. Okay, you cannot just write FBB plus FBC, cannot. Okay, we must pair with the redundant. So we write the equation as this. Okay, so we have delta B naught FBB times BY F FCB times CY. Kita tengok betul ke tak tadi tu? FBB FBC FBB FBC times CY. FBB FBC ya. FBB FBC. Takut nota ni saya tak update. Nota lama ni. FBB FBB times CY FBC actually. Sini betulkan ya. Please betulkan sini. Okay. Betulkan FBB times BY FBC. FBC times CY. Refer back to this diagram. Yang ni tadi. FBC times CY. Because we refer to the position B. Position B. Position B. So it is FBC times CY. Kita tengok dia sebaris ya. Kita tengok dia sebaris macam ni. Don't worry. Don't worry too much. This is just for derivation. Solution will be more easier than this. Okay. Sebaris ni. So it is FBC. For equation number 2, it is FCB. FCB because I made this note more than 10 years ago. Masa tu saya baru je refresh balik flexibility method ni. Okay. This line. Tengok this line. It is delta C naught. Delta C naught FCB. FCB FCB times BY. FCB times BY. FCC times CY. FCB times BY. FCC times CY. So FCB. The correct one is FCB. Okay. This is equation number 2. Okay. Equation number 1 and equation 2. Okay. Now these two equation, kita tulis balik kat sini. Saya ambil balik. Kita patah balik pergi diagram tadi. Sini. Okay. So we have delta B naught plus FBC times, BB times BY plus FBC times CY equal to 0 as the first equation. And we have delta C naught plus FCB BY plus FCC CY. This is equal to 0. This is equation number 2. Okay, so these two equation is actually the two simultaneous equation which we can transform into matrix form. Kita nak transform this into matrix form. Okay, and that form will be the standard form of compatibility equation for two redundant. Okay, so we change this to matrix form. This is delta B naught, delta C naught. Delta B naught, delta C naught. We group the two displacement in primary beam in one matrix. Okay, in one matrix, delta B naught and delta C naught. Plus we group all these all F come from two redundant system in one matrix, 2 by 2 matrix. This is 2 by 2 matrix because there are two redundant. Two redundant will produce 2 by 2 flexibility matrix. Okay, 2 by 2 flexibility matrix times with BY as the first redundant times with CY as the second redundant equal to 0. Okay, so this is FBB, FBC, FCB, FCD. Okay, so this is actually the compatibility equation. Compatibility equation, we group these two. These two are displacement in primary beam. Displacement in primary beam, delta B naught and delta C naught, redundant 1 and redundant 2. And then we group for F, which come from two redundant beam, two redundant system. We get 2 by 2 because there are two redundant. If we have 3 redundant, we will have 3 by 3 matrix. And this group of matrix is called as flexibility matrix. Flexibility matrix. And matrix must have the matrix characteristic. Matrix will always have the matrix characteristic. And matrix characteristic is symmetry. The matrix, the value must be symmetry, because kalau dia matrix, dia akan apply all the matrix characteristic. And one of the well-known characteristic of the matrix is symmetry. Okay, so we have FBB, FBC, FCB, FCC. Sorry, FCB, FCC sini. Sini FCC. Okay, so we group this for F and times with BY and CY. BY is the first redundant. CY is the second redundant. Okay, BY is the first redundant. CY is the second redundant, equal to 0 because the roller support at B, the roller support at B, the roller support at C. Okay, we get equal to 0. Okay, so this will be the format of the compatibility equation. Okay, for two redundant structure. Okay, kita tengok balik kat sini. Bila kita okay, actually dikembang balik FBB kali BY, FBC kali CY, sama tak dengan ni? Sama tak?
Sama.
Sama kan? Sama. Okay, sama juga dengan yang bawah tu. Okay, sama juga dengan yang bawah. FCB kali BY sama dengan yang ni. FCB kali BY sama kan? And satu lagi FCC kali CY sama dengan yang ni. It is matrix multiplication. Matrix multiplication. Sama juga. This is the matrix characteristic. Okay. We multiply matrix. We multiply matrix. So this is the format. Okay. So this format is true for set number 1. Set number 1. Whenever BY and CY as the redundant. As the redundant. Tapi lepas ni kita akan jumpa macam-macam bentuk soalan dan macam-macam position of redundant. Okay, redundant can be MA and CY. Redundant can be MA and BY. or we can have another structure where the redundant may move to the other position. Okay, so we should or we manage to have the the standard format which can be applied to all problems. Kalau B dengan C ni dia hanya untuk B dengan C je lah kan. Actually kalau untuk MA and BY as redundant, we don't need to show, we don't need to derive like this. So this is just to show to you how we get the equation, how we get the compatibility equation. So we will summarize this derivation of compatibility equation. Okay, for two redundant like this. Okay, in one standard form, R1 is BY, R2 is CY. One standard form, R1 is BY, R2 is CY. It means that we will change all B to 1, all C to 2. Okay, so using back this equation, all B we will change to 1, all C we will change to 2. All B we will change to 1, all C we will change to 2. We will write one standard form of compatibility equation. Okay, standard form of compatibility equation. Okay, we will have standard form of compatibility equation. Okay, we always write with the primary system, and then we will have 2 by 2 flexibility matrix, 2 by 2 flexibility matrix plus this is 2 by 2 flexibility matrix. Okay, and again flexibility matrix cannot stand alone. We must times with redundant number 1 and redundant number 2. Redundant number 1 and redundant number 2. Okay, and this is equal to displacement at both redundant position in actual beam, redundant 1, redundant 2. Redundant 1, redundant 2. Okay, so the first, okay, in the first bracket, we group the two displacement in primary beam. Okay, the two displacement in primary beam. Since, okay, we use delta since this is BY and CY. So it is delta. Okay, delta. Okay, so for redundant number 1, so we use 1. Redundant number 1, we use 1. 1, not. Not is symbol for the primary system. Okay, line number 2. Line number 2 for redundant number 2. So we use, instead of using C, we use 2 to show that this is for redundant number 2. So we use 2. And don't forget, we have to put not. So these two, delta 1 not and delta 2 not, are the displacement or deflection in primary beam. Because in primary beam, we have two position, two redundant position. Redundant 1 is BY, redundant 2 is CY. So we write like this. Okay, so when we move to the next bracket, it is matrix 2 by 2 because we have 2 redundant. So all this is F. F is flexibility coefficient. Flexibility coefficient. Okay, by looking at the previous, BB will change to 1, 1. BB will change to 1, 1. BC will change to 1, 2. Okay, 1, 1. BC become 1, 2. CB become 2, 1. CC becomes 2, 2. Okay, we just need to change from B to 1, from C to 2. Okay, so now we have flexibility matrix. Flexibility matrix, and it is 2 by 2 matrix, and the matrix is always symmetry. Matrix is always symmetry means F12 will be equal to F21. Okay, next bracket is for the redundant. For the redundant. Okay, you can write R1 and R2. Means for the whole type of question, it is R1 and R2. But if you put R1 and R2, we do not know whether it is for forces, or it is for moment. So I prefer to write the redundant name here. So it is redundant number. We know that this is the upper one is for redundant number 1 because it is line number 1. Okay, so for R1, we put, instead of putting R1, we put BY, so that we know that, oh, this is BY, so it should be delta. If we put MA, it should be theta. If we put all R, we do not know which is delta, which is theta. So I prefer to put here BY, and for the second redundant, it is CY. So I put CY. And this is equal to 0. So this equation is the compatibility equation, the standard form of compatibility equation. Standard form of compatibility equation. Okay, standard form of compatibility equation. Whenever redundant number 1 is BY, redundant number 2 is CY. So this is the standard form. Okay, the standard form. And you need to remember this format. You need to remember this format. Okay. Is it okay? Is it okay?
Oh, yes.
Okay.
Okay. So this is the standard format. Of course, you can write R1, R2, tapi tak payahlah letak je nama redundant tu kat situ. Okay, you just letak nama redundant kat situ so that we can identify clearly. Okay, we can identify clearly. Means that, okay, yang ni is when R1 is BY, R2 is CY. Tadi kan kita ada three set of solution. We have this is when we have set number 1. R1 is BY, R2 is CY. So what happened? What if we change the redundant? What if we change the redundant? What if we change the redundant? What happened? Okay, for example, now we change to set number 2. Remember set number 2 just now? Set number 2, we have R1 is MA, R2 is BY. Okay, so what happened? What happened? We can, okay, we can write the format, this compatibility equation, the standard format, okay, directly, okay, after we choose redundant. Okay, and we just need to change R1 now. We change to MA. MA. So bila dah faham, kita tak perlu derive. Derive tu just for explain to you how we get the relation, how we get the compatibility equation. Okay. So bila nak solve after this, kita akan start dengan identify number of redundant, choose redundant, terus write this equation. So the first one is MA now, the second one is BY. So we just need to change this. So when MA is the redundant, the delta we should change to what? Change to, because MA is the redundant number 1. Change to moment induced
Theta.
rotation. Moment induced rotation. So it should be rotation. Okay, because MA is the redundant. So theta 1 knot. It should be theta 1 knot, not delta 1 knot. Okay, when MA is the redundant. So in this case, F11 and F12 is actually the rotation as well. F11 and F12 is the rotation as well. So kita nak identify dia macam ni je. Okay, dia sama macam konsep kita write two simultaneous equation. Okay, you tengok first position is first notation is position. Okay, so dia akan standard. Ini 1. Kalau sini 1, tiga-tiga ni akan jadi 1. Nampak tak? And this is actually R1. Okay, dia sebaris tu. Line ni memang line number 1 ni. Line number 1. Line number 1. Line number 1. Semua yang notation, the first notation tu 1, 1, 1. MA is R1. Okay, clear yang tu? Clear yang tu? Clear tak?
Ya, madam.
Okay. Okay. Redundant number 2. Redundant number 2. Line number 2. Line number 2. That's why sini 2, sini 2, sini 2, sini pun 2. Sini pun 2. So semua tu line number 2. Position redundant number 2. Okay. Second notation tu, yang belakang ni, primary beam. Redundant 1, redundant 2. Nampak tak? Second notation. Second notation. Okay, second notation. Type of beam. Second notation for type of beam. Primary beam, redundant 1, redundant 2. Get what I mean? Okay, again yang bawah. Primary beam, redundant 1, redundant 2. So how many determinate system we will analyze? How many? How many determinate system? Primary beam, redundant 1, redundant 2. How many determinate system we are going to analyze? How many?
3.
3. Okay, 3. 3. Primary beam. Primary beam. The first system. The first system. Primary beam. System number 2. System number 2. It is for redundant number 1. For redundant number 1. It is redundant MA in this case. MA applied. Redundant MA applied. Okay, next. 2 ni. What is this 2? Redundant Redundant? Redundant?
BY apply.
BY. Applied. Redundant. BY. Applied. Okay? Clear? Concept? Clear the concept? We do one example. Kita tengok ada tak soalan yang kita boleh insert sini Indeterminate beam. Indeterminate beam. Yang ni one redundant. This is how many? This is 1, 2, look like 3 Look like 3. Oh no, this is 2. This is 2. 2, 3, 4, 5. 2, 3, 4, 5. We can analyze this. Okay, so we take this. We take this as the discussion for today. Okay, yang ni I do not know from which university. So I just insert from online. Okay, so this is indeterminate beam. This is indeterminate beam to the second degree of indeterminacy. Okay, soalan dia draw bending moment diagram ni. Determine bending moment diagram. Draw bending moment diagram. Okay, forget about this term first. Kita akan tengok after this. Yang ni kita forget it first. Yang ni. This statement, we forget it first. Okay, kita analyze this. Okay, without, okay, yang ni dia mention about support settlement. Okay, forget about that first. So we just focus on the structure. Focus on the structure. So L is 5. Let's say L is 5. Let's say L is 5. Okay, let's say L is 5. Okay, let's say L is 5. L is equal to 5 meter. L is equal to 5 meter. Okay. Besar sangat saya kecilkan sikit diagram ni. Okay, so just look at the diagram. Okay, now just look at the diagram. So let's say L is 5. L is 5. So saya actually nak besarkan font. Sekejap Tak ada ni font ni. Aku ambil 16. So L is equal to 5 meter. L equals to 5 meter. Okay. So we are going to analyze unknown reaction. Unknown reaction for this beam. There are 5 unknown reaction. We have 1 pin at A, 1 pin at A, and 3 rollers at B, C, and D. At B, C, and D. Of course, after we having all the reaction, we can continue to draw shear force diagram and minimum moment diagram, but we focus first on the reaction. Okay, so forget about the support settlement given in the question, because we will analyze without any settlement effect. Okay, so first step we identify redundant. It is 5 minus 2 minus 3 is equal to 2 is equal to 2. Okay, means that there are two redundant. There are two redundant. So next step is we choose redundant. We choose redundant to remove from the system. We choose redundant. So we have R1. Okay, we have R1. Let's say, okay, we remove BY and CY. We remove BY and CY. So BY is the first redundant. BY is the first redundant, and we have redundant 2, redundant 2. Let's say CY is redundant 2. Okay, so these are the two redundant that we are going to remove from the actual beam. And after removing redundant, the beam will change from actual to determinate beam. Okay, and from this we can straight away write the standard form of compatibility equation. The standard form of compatibility equation. Okay, standard form of compatibility equation is equal standard form of compatibility equation. Okay, so the first for the first bracket, it is for displacement in primary system. In primary system, okay, it is delta. Both are delta. So it is one node standard symbol. Okay, the two node, one node and two node, and we have F flexibility coefficient for F for position of displacement, 2 in redundant 1, 2 in redundant 2. Okay, the standard matrix format for 2 by 2 will be 1, 1, 1, 2, 2, 1, 2, 2. This is the standard format of matrix 2 by 2. Okay, times with redundant. You can put R1 and R2, but I like if we can put the right redundant name here. Okay, we put BY as the first redundant and CY as the second redundant. And this is equal to 0 without support settlement. When the structure got support settlement effect, we will change the displacement in actual beam. Now we just ignore the settlement given. We just ignore the settlement given. Sekejap Okay. So this is the compatibility equation. So inside this compatibility equation, we have the two redundant that we are going to analyze using this equation, and there are six displacement. There are six displacement. Delta 1 naught, delta 2 naught are the displacement in primary beam. In primary beam, F11, F12, F21, F22. There are four displacement in two redundant beam. Okay, we combine in one matrix. We combine in one matrix. So there are in total six displacement come from three system. Six displacement come from three system. And the delta, the displacement, six displacement will be determined using the displacement formula. For beam and frame, we will integrate the two moment equation. We will integrate the two moment equation. Okay, this two moment equation, okay, not two moment equation. We will have three moment equation because we have two redundant. Two redundant, we have three moment equation. Okay, so we have six displacement. We have six displacement. We have delta 1 naught. Delta 1 naught. The formula is 1 over EI. 1 over EI. The same formula, of course. Okay, we integrate. We integrate from 0 to L. From 0 to L. It is two moment equation in one formula. It is M1 M naught. It is M1. This is M1. And because we follow whatever notation that we use. So this is M1 M naught. M1 M naught. Okay. dx. This is the first formula. Okay. The second one is delta 2 naught. Delta 2 naught. Okay. It is delta. This is delta 2 naught. This is delta 2 naught. Okay, delta 2 naught. This is equal to 1 over EI. 1 over EI integrate from 0 to L. From 0 to L, it is M2 M naught. M2 M naught. It is M2 because we always refer to the notation. M2 M naught. Okay, this is dx. Okay, next is F11. Next is F11. Apa dia formula for F11? F11, what is the formula? 1 over EI. Lagi? Integrate 0 L. F11 means we have to integrate M1 M1. M1 M1 is M1 square. M1 M1 M M1 M1 square dx. Okay, M1 square dx. This is F11. we have F12, F12, which is equal to F21, F21 equal to 1 over EI integrate from 0 to L, from 0 to L, this is M1, M2, M1 and M2, because we just need to use the notation, okay, that we use, dx. Okay, and lastly is F22. F22 equal to 1 over EI integrate from 0 to L. Okay, it is M2 squared. M2 squared dx. M2 squared dx. So these are all the six displacement formula. Six displacement formula. So inside this, we can find that there are three moment equation. Three level of moment equation start from M0, M1, M2. M0, M1, M2. Sama macam tadi when I mentioned about this. There are three system. The first system is the primary system. Not is always symbol for the primary system. Redundant 1 is redundant by applied. Redundant 2 is redundant cy applied. So we have three determinate system. We have three determinate system. We have primary beam. And in primary beam, we will write the moment equation M0. Okay, in primary beam, we will write the moment equation M0, and we will have the second system is for redundant by. Redundant by applied. And in redundant by applied, since it is redundant number 1. Redundant number 1, so it is M1 for redundant number 1. Okay, and we have redundant cy applied. Redundant cy applied. Cy applied, and this is redundant number 2. This is redundant number 2. So this is M2. M2. Okay, redundant M2. So we have primary beam for M0, redundant by applied, since we call this as redundant number 1, M1, and redundant cy applied is M2. Okay, so we have three systems. So in In these three systems, we have to analyze actually simply supported beam. It is simply supported beam. Allah. Okay, so simply supported beam. A, B, C, D, UDL. Okay, it is 4 kilonewton per meter and 15 kilonewton point load. So length is 5 meter. 5. So this will be 2.5 and 2.5. Okay, this is primary beam. This is primary beam. Okay, now please calculate AY and DY for this beam. Calculate AY, calculate DY for this beam. AB, okay, AB has UDL 4 kilonewton per meter and CD is subjected to point load 15 kilonewton located at the center. So length will be 2.5, 2.5. Okay, now please calculate AY and DY for primary beam. And tell me the answer. Okay, so we have three systems. Primary beam, please calculate reaction. We have redundant beam. Redundant number 1, redundant BY applied. So this is a simply supported beam subjected to a unit value of BY. And we have redundant CY applied. So we have same type of beam subjected to a unit value of Cy. So please calculate reaction for all these three beam. Please calculate reaction and tell me the answer, the reaction. Okay, what is the answer for AY and DY in primary beam? Okay, berapa nilai AY and DY? Cepat-cepat nak habiskan sebelum pukul 11 ni. AY and DY?
Madam, is it AY equals to negative 30.83?
The rest? Apa 30.83?
Yes,
Saya
ada.
dapat negatif 52.5. Betul ke?
Ada lagi jawapan lain? Ada lagi tak jawapan lain?
AY saya dapat 19.17.
Banyaknya jawapan. So we lagi jawapan lain lagi? Ada lagi other than that?
17.5.
Banyaknya jawapan. Tak apa, kita tak mesej apa yang keluar kat situ. Kita ada dah. Okay, so we have this AY, DY, 15 dengan 4 kan? 4 right? A, B, C, D. Right. This is 5, this is 5, and 2.5, 2.5 lah. Okay, so taking moment at A, it is 4 times 5.
4.5.
Times 2.5. Lagi minus plus juga plus 15 kan tu?
Ya.
15 times 10. 10. Lepas tu minus bukan 10. 12.5. Kan? 12.5
Ya,
kan?
betul, betul.
12.5. Minus 15. Kan? So dapat apa ni dy? 4 times 5 times 2.5 plus 15. 12.5 divide by 15.
1583.
Tolong calculate ya. Tolong calculate. 1583 kilonewton. Okey? Dapat tak jawapan ni?
Dapat.
Okey.
Dapat.
Okey, 15.83. So yang ni saya letak 15.83 lah. So this is 15.83. 15.83. Okay, please calculate AY. 4 times 5, 20. 4 times 5, 20. 20 plus 15, 35. 35 minus 15.83.
1917.
1917. Okay, 1917 AY. 1917 AY. Okay, eh? Okay, this is reaction in primary beam. Okay, we move to redundant BY applied. Redundant BY applied, please calculate AY and DY. AY and DY for redundant BY applied. Macam mana nak calculate yang ni? AY, DY, a unit value of BY. So distance sini 5 meter. Sini 10 kan? Sini 10. Okay, again taking moment at A. Taking moment at A. It is -1 times 5 minus 15 ya. Betul kan? So dy equal to negative berapa ni? 1 divide by 3. 0.3.
3.
3.
Betul.
1 over
Okay.
3.
Okay, 0.333. dy kan yang tu. dy. dy is 0.333. Okay. AY? 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 7. Okay. So, balance kan? Dah balance. Okay, now. This one. Redundant CY applied. dy dapat? dy dapat apa? Balik kan? dy dapat 0. Betul tak dapat 667 sini? Dengan 0.333 sini? AY, dy, a unit value kat sini. This is 10, this is 5. Kan? 10 dengan 5. So, ini 1. 10. So, yang ni negatif 2/3. So we get 0.667. Betul. Okay, everyone?
Ya, betul.
Dapat Okay. Now we have to write the moment equation. Okay, which we will get from three system, M0, M1, M2 from primary beam, redundant BY applied and redundant CY applied respectively. And don't forget to include another point at 15 kilonewton point load. Okay, now we have A, B, C. We will have E. This is compulsory. E. Okay. We have to put E here. We have to put E here. At point load. Okay, because we will have equation. Okay, which is between C to E, we will have one equation. Between E to D, we will have another equation. We cannot assume that CD is one cutting section whenever we have point load like this. So we have to add another point. Let's say we put as E. We put as E, so it will become CE and CD. Okay, so in total, how many cutting section do we have now? How many cutting section do we have now? Cutting section. 1. For A and B, we have 1 cutting section. 2 cutting section. For B and C, we have 2 cutting section. For C and E, we have another cutting section. For E and D, we have another cutting section. So we have 4 cutting section. We have 4 cutting section, and we must have 4 cutting section in redundant beam as well. Okay, if in primary beam we have 4, redundant must follow. So in redundant, we must remain these 4 cutting section. Okay, same goes to redundant CY applied. Semua ni dah bukan flexibility method lagi. This is just how we write moment equation. Yang ni balik pada solid mechanic lah. Okay, yang you dah belajar write the moment equation. Okay, so we have 4 cutting section. So sebab ada 4 cutting section, we tabulate, we will write the moment equation and we put into the table. We put into the table. So we have member, okay, member origin, and 0, 1, 2. Okay, 0, 1. So we have okay, we put okay, this is for M. We have 3M. We have 0, 1, 2. Okay, primary system, redundant 1, redundant 2. Okay. We have 4 cutting section. We have 4 cutting section. We have 4 cutting sections. Start with AB, and then BC, and then CE, and then ED. Okay, we have 4 cutting section. Okay, we have 4. AB, BC, CE, ED. Okay, for AB, origin we choose A. Okay, origin we choose A. Okay, dia punya tips kan, kalau kita nak maintain limit tu from 0, 0, for example 0 to 5. Length of AB is 5 meter. Kalau kita nak maintain limit to 0 to 5. Okay, so sini pun 0 to 5. Sini 2.5. So 0 to 2.5. 2.5. And 0 to 2.5. Kalau nak maintain semua limit to start from 0. Origin mesti salah satu daripada yang ada dekat sini, AB. So kalau AB origin A limit 0.5, kalau AB origin B also 0.5. But we always take the shorter section. So for AB, the shorter section is when we choose A as origin. Okay, BC origin C. BC, we can choose C as origin. We can choose B as origin to use 0 to 5 as the limit. Kalau you choose A as origin, limit cannot be 0 to 5. It will be 5 to 10. Kalau you nak maintain 0 to 5 for limit, okay, because the length of BC is 5, so you kena choose either B or C as the origin. So let's say we choose B here. B. Okay, sama juga CE ni. CE kalau kita nak use, if we want to use 0 to 2.5 as the limit, kita kena pakai origin salah satu daripada C atau E. Okay, so let's say we choose E. Okay, and yang ni we choose D. Okay, E as origin sebab E adalah salah satu daripada C dengan E. So kita boleh pakai limit 0 to 2.5. Kalau origin yang kita pilih tak ada dalam tak ada dalam BC ni. BC origin A limit bukan 0 to 5. CE origin A bukan limit 0 to 0. Limit dia lain ya. Okay, now we try to set limit semua start from 0. Ini option only. Okay, because you can choose any origin that you like. Doesn't matter. But remember, origin menentukan limit dan menentukan kita punya diagram, free body diagram. Okay, free body diagram. So kita akan buat satu-satu yang ni. This is actually revision, tapi tak apa, kita do it as revision. Again, so we will write M0, M1, M2 for all these 4 sections. Okay, we will start with AB origin A 0 to 5. AB origin A. AB origin A dekat sini. AB origin A. AB origin A yang ni. Moment macam ni. Okay. Because we take origin from left. When we take origin from left, moment is counterclockwise. Because origin kita A. Origin from left, moment counterclockwise. So section ni become, saya tulis dekat tepi ni. Tadi kita dapat berapa tadi? 19. Is it 19? Sini 4 tadi kan? 4. 19.17 isn't it?
Yes,
19.
okay.
19.17. 19.17. Moment is counterclockwise sebab origin start from A. origin from left. Origin from left, moment. So this is M naught lah. This is M naught. Okay. So the moment equation for this one, by taking moment at the cutting point, total moment at the cutting point is equal to 0. So it is negative M naught plus 19.17x minus 2x square. Betul ke salah ni? Betul ke salah? It is 19.17x minus 2x square. Is it the right one? The right equation? Please check. It is 19.717 times x, it is positive. 4 times x over 2, it is 2x square. Okay, m we bring to the other side, so it is m not equal to 19.17 x minus 2x square. Is it correct one? Is it the correct one?
Yes.
Yes, ya. Kita tengok dia boleh tak change to kat mana nak change ya? Draw. Betul 19.17x minus 2x2. Okay, so we want this. Copy. Ini ya. Okay, so AB origin A, limit 0 to 5, it is 19.17x minus 2x2. Okay, now we will write the equation for BC origin B 0 to 5. 0 to 5. Origin B. Origin B. Okay, origin B, cutting section sini. Okay, the cutting section, origin B. So we have to take from A, even though it is origin B, but we have to consider section start from A. Only X start from B. Okay, we draw the diagram. Draw the diagram. So yang ni. Lepas tu, so we have 19.17. 19.17. Tadi 4 kat sini kan? Okay, so sini A, B, see something here. So moment kita counterclockwise, origin from B. Origin start dekat sini. Means that all this we measure as this is 5, this is X. Sebab dekat sini X is equal to 0. Dekat sini X is equal to 5. That's why limit tu from 0 to 5. So X dia between X is start from B. Okay, so to write the equation for this, this is M. So this is M naught. This is M naught. Okay, now we write the moment equation by taking moment at the cutting point. It is negative M naught plus with 19.17, it is 5 plus X. 5 plus X. Distance from A to cutting point is 5 plus X. Okay. And now we have 4. So we minus 4. 4 times 5. Okay, 4 times 5 is located at the center. It is 2.5 times X. 2.5 times plus X equal to 0. Sebab distance 4 ni when times with 5, it is point load at the center. Kan? Dia dekat sini. Dia dekat sini. And distance ni dekat sini, and distance ni is 2.5. So sini is 2.5 separuh, sini X. So it is 2.5 plus X. 2.5 plus X. Yang ni lah. So we get M naught equal to 19.17 times 5. Dapat apa? 19.17 times 5. Cepat.
95.85.
95.85 plus 19.17x minus 4 times 5, 20. 20 times 2.5.
50.
50 minus 20x. Okay, simplify what we get. 95.85 minus 50, 45.85. Minus, it is minus, right? Minus 0.83. 83x. 0.83x. Okay. Uh, 45.85 minus 0.83x. Okay, this is equation. Kejap tadi. Sini Kenapa M1 lari pergi sini dah ni? M1 dekat sini. Okay, so this is the equation. 45.85 minus 0.83x. Okay, origin is B, limit 0 to 5. Okay, okay, we write ED origin D first. ED origin D. ED origin D. ED origin D. This is the cutting section. Since X is located at D, means X is means origin from right. Origin from right means moment direction clockwise. Moment is clockwise. When origin come from right. So moment is clockwise. Moment is clockwise. So we have this is M naught. Okay, this is D. What is the value here, dy? 15.83, right? 15.83. So this is X. So this one will be M naught. M naught is 15.83x. Is it correct? Allah, salah. Boleh balik. 15.83x. Betul salah? 15.83x. Betul tak ni?
Betul kan?
Okay, 15.83x. So yang ni ED origin D ED origin D 15.83x. Okay, now CE origin E. CE origin E 0.25. Okay, let's look at the section. CE. Okay, dia dekat sini lah. Dekat sini. Okay, ada 15 kilonewton tu. Be like this. This is 15. This is 15.83. Okay, so this is D. This is E. This is C. Cutting here. Moment clockwise because origin from E. So means that yang ni this will be X. This is 2.5. Okay, and remember origin. At origin X is equal to 0. At C, X is equal to 2.5. Sebab tu, dia punya limit is 0 to 2.5. We measure from origin. Okay, from origin, 0 to 2.5. That's why limit dia 0 to 2.5. Okay, so this is the moment equation. Okay, write the moment equation for this. Okay, it is M naught plus 15 times X. 15 times X. Lagi, we get minus apa tu? Ni apa? Minus kan?
Yes. DY.
Okay, L dia X plus 2.5. Dia total length ni kita tambah this and this. So length tu is X is X. This is X plus 2.5. Okay, from D tu. From D. Okay. So simplify this. We get M naught. M naught equal to negative 15x plus 15.83 3x. Okay, please calculate what is 15.83 times 2.5.
39.58.
39.58, yeah? 39.58. So what we get here, it is apa ni? 0.83 lagi, kan? 0.83 x plus 39.58. Betul tak ni? Is it correct one? Is it the correct one?
Yes, betul.
Okay. Okay, now we change this to 0.83x plus 39.58. Correct? So this is for this one. Okay, so we get all moment equation. We get all moment equation M naught for the primary beam. For the primary beam. Okay, we will do the same for redundant 1 and redundant 2. Redundant 1 and redundant 2. So yang ni kan, this is option lah. Kalau you nak remain, yang ni SA pun boleh, yang ni SD pun boleh, doesn't matter, it's up to you. Yang mana you rasa comfortable with, doesn't matter. But please remember, when you choose A as origin, this one become 5 to 10. This one become 2.5 to 5. So dia akan follow the origin. Doesn't matter which one you want to choose as origin. Okay. Okay, now we move to this redundant BY applied. Redundant BY applied. So we get AB for section AB. M1 is negative 0.667 x. Negative 0.66. 0.667 x. Okay. And for DE ni, it is negative 0.333. Please check, yeah. Please check whether it is correct or not. Please check. Okay. And we need to calculate, we need to write the moment equation for BC and CE by taking origin B and origin E respectively. So this one. Okay, this one. A, B, C, D, E. So we have BC, origin B, X kat sini. And we have EC, origin E. This is M, origin dekat sini. So distance dia. So sini 5, sini X. So this one also same. Sini 2.5 2.5. 2.5 sini X. Okay. So what about the section? Dia bawah ni lah ya. Okay, so we have this. A unit value dekat sini. Tadi kita dapat ni berapa? AY tu 0.667. 0.667. So distance dia. So this is M1. So distance ni is X. Distance ni is 5 plus X. Okay, so we write equation. So this is negative M1. Negative M1 plus 1 times X plus 1 times X minus 5 minus 0.667 times 5 plus X. So we get M1 equal to X minus, please calculate 0.667 times 5 equal to
3.335.
3.335 ya. Okay, minus 0.667x. So this is equal to 0.333x. Okay, minus 3.335. Sini ya. (0.333x minus 3.335). So this is for this. Okay, so CE, what about CE origin E? CE origin E. Okay. CE origin E. Sini. Origin. So we have 0 point. Sini apa nilai dia tadi? 0.333 eh. 0.333. 0.333. X dekat sini. Sini X. Sini. A, B, C. D. C dekat sini. E dekat sini. Okay. So sini X is equal to 0. This is 2.5. So distance ni is 2.5. 2.5 plus X. This is moment M1. So it is M1 plus 0.333 times 2.5 plus X. 2.5 plus X equal to 0. So M1 equal to, what do you get? 0.333 times 2.5?
0.833.
833 minus 0.333x. So this minus Cannot. So boleh balik. Minus 0.333x. Okay. Ada negatif kat depan kan tadi. Negatif. So this. So this will be the equation. Okay. So we will do the same for M2. M2 yang ni. M2. Okay. AB is negative 0.333. Okay. DE also 0.667 negative. Okay. So we have to write. Okay, the moment equation. The moment equation mana tadi? Okay, ni. Ni tadi. So yang ni A, B, C, D, E. So we have BC here, CE here, moment like this, moment like this. Okay. So yang ni distance is 5 plus X. Yang ni the distance is X plus 2.5. Okay. X plus 2.5. Sama macam tadi. The same process. So we get. Sambung mana? Saya sambung tepi ni ya. Nanti kalau you nak refer, you just scroll dekat tepi tu. Okay, we have. So A, B, C. Moment between B to C. Origin dekat B means that this distance is equal to 5 and X. 5 plus X. 5 plus X. Berapa nilai AY tu? AY 0.333 ya. 0.333. 0.333. So this is M2. M2. So what we get is negative M2 plus 0.333. 5 plus X 0. So M2 equal to 0.333 times 5. Dapat apa?
1.665.
1.665. 1.665 plus 0.333x. Okay. Okay. This one. Okay, and last one. Last one. Okay, yang ni. Memang kena careful when writing moment equation. Ramai yang dia bukan tak faham flexibility method, tapi sebab step yang panjang pada moment equation ni. Sini apa? 0.667 dia. 667 kan? 667. So, ni. This is M2. This is M2. And this is ABCD. ABC. C kat sini. C, D. E dekat sini. So we want to write moment equation between C to E. Between C to E. So X kita dekat sini. So this is X. We want the equation that is right between this distance. Okay, so it is 2.5. 2.5 and X. So it is X plus 2.5. Okay, X plus 2.5. So for the moment equation, so we get M2 plus 0.667 X plus 2.5. Okay, so we get M2 equal to negative 0.667. Okay, please calculate 0.667 times 2.5.
1.668.
668. 1.668. Negative 0.667 X minus 1.668. Okay, now we complete. Okay, different origin will give different equation. Okay, different origin will give different equation and different free body diagram. Okay, careful ya, careful. So these are all the moment equation. Nampak soalan macam simple kan? Okay, but bila ada banyak cutting section, so you have many moment equation and many cutting section, and then you have three system M0, M1, M2. So moment equation. This is moment equation. So that is why I said bila nak determine displacement, do not need to rewrite the equation. The equation ni, the moment equation into the formula. Because kalau you everything you nak tulis, you memang takkan boleh siap within the time given. Okay, that is why just use calculator, integrate. Because we know that from this, okay, we will have 6 displacement. The formula will give us what's next to do. Okay, so when we want to calculate, for example, delta one node, so we just focus on this column and this column, and we have to do one by one section lah. We have to do integration for AB, and then we need to plus with integration for BC, plus with integration for CE, and plus with integration for ED. Then only you get the answer. Just put the answer, doesn't matter. Okay, just put the answer. Letaklah whatever answer kat sini. So just put the answer per EI. So semua ni just letak the value. Do not rewrite the equation. You dah spend time untuk write the moment equation. Jangan buang masa letak lagi equation dalam formula. Okay, just refer to the table. Use calculator. Do not integrate manually. Do not integrate manually. And substitute. Just substitute into calculator and you will get the displacement. So I believe once you dah dapat displacement ni, you dah boleh continue. Okay, saya tak nak continue sampai pukul 12. So I want to stop right here. But I want you to continue. Please Okay, please continue calculate all these 6 displacement. 6 displacement, please put the value inside here. Okay, and then write the compatibility equation because the next step is compatibility equation. Compatibility equation. Compatibility equation. Okay, now dah masuk phase kita nak gantikan all the symbol dengan nilai. Okay, the compatibility equation. So ambil balik this equation. So gantikan all the 6 displacement into the compatibility equation. Into the compatibility equation. So dah ganti all the value dalam this compatibility equation. Dah ganti all the value there are 6. Okay, 6 displacement. So we will normally put EI, since EI is constant. EI constant. So dalam soalan dia tulis EI tak? Okay, EI constant. EI constant. Okay, we will write the compatibility equation in terms of EI. In terms of EI, so nanti dekat sini kita akan write the equation in terms of EI means tinggal macam ni lah. Dekat sini ada 1 over EI. Dekat sini you have to put the answer lah. You have to put the value. You have to put the value. And then this one also do not forget to put EI. 1 over EI yang ni. 1 over EI. Okay, so F11 sampai F222 please replace with the value. The value, the displacement. Okay, replace this with value. Please replace this with value. 6 displacement that you get from the formula above. Okay, so you will get something like this. So yang ni nanti ada 6 value lah, 6 value. EI put outside. EI put outside, so we have all this value. So when we solve this, when we solve this, we will get BY and CY. And actually we solve this compatibility equation by actually solving two simultaneous equation. Kan tadi dia memang datang daripada simultaneous equation. Cuma kita transform dia jadi satu standard form of compatibility equation yang kita tulis in matrix form. Tapi for the solution, we know that this is actually simultaneous equation. Tak payahlah kembang balik jadi equation. No need to do that. Cuma nanti bila you dah ada value, you just key in the value, use calculator, key in the value. So dekat sini nanti this is A, this is B. A dengan B, nanti kita nak solve dia macam ni. Bila kita nak solve, kita akan solve dia macam ni. Bila kita nak solve, dia jadi macam ni. Okay, bila nak solve, you kena susun dia dalam bentuk macam ni. So this will be A1. This is B1. This is C1. This is A2. This is B2. This is C2. So put all this into calculator. Use simultaneous equation. Put AY sampai C2. Then you will get X which is equivalent to BY. X which is equivalent to BY. And X and Y. Y is equivalent to CY. So you get the redundant. You get the redundant. And then dah dapat these two redundant, you can actually calculate. After this, you need to calculate the remaining reaction. Okay, using either equilibrium equation. Dah dapat dua redundant. Remember kita punya aim, kita punya goal is to calculate reaction. Reaction ada 5. 2 cannot be calculated using equilibrium equation. Only 3 can be calculated using equilibrium equation. So lepas dah dapat these two, we can solve this remaining reaction using equilibrium equation. And actually we have another option yang lagi senang daripada equilibrium equation, that is using principle of superposition. So tengok balik video, previous video yang mana saya ada explain about solving remaining reaction guna another option that is called as principle of superposition to determine remaining reaction, and it is actually easier than using equilibrium equation. Okay, so please complete this one. So means that dah complete yang ni, kita dah cover lah, kita dah cover beam, 1 redundant, 2 redundant. Please complete this before we continue to the next session. Kita akan tengok effect lah, effect in beam. Dan lepas ni mungkin kita akan fokus dekat frame pula, sebab beam dengan frame have same analysis. So kita akan fokus on frame as well, dan juga truss. Okay, and kita akan tengok also effect pada beam frame as well as truss. Okay, so before we end session, do you have any question?
So far, no, Doctor.
Okay, please please complete this. Kalau you tak try to complete this, benda ni kan dia memang perlukan level of satu basic kena strong, satu exercise kena banyak. You have to do lots of exercise. Kalau you tak buat exercise yang banyak, regular exercise lah, bukanlah banyak sangat, tapi macam make it regular. Okay, make it regular, because bila benda tu regular, you tak lupa benda tu. So nanti dah belajar topik baru, kalau you tak buat ni as habit, regular exercise, you akan lupa all this, and then bila nak exam nanti nak kena patah balik, nak kena start balik daripada awal. Tapi kalau you make this as regular, make this as habit, so everyday buat, so you takkan sempat nak lupa pun benda ni semua. Benda ni is actually all the analisis dalam ni, semuanya kita analyse determinate beam, kita analyse kira reaction, writing moment equation, semua ni adalah apa yang you have learned previously. Okay, learn previously. Tapi you kena ada strong basic lah, especially in writing moment equation. Okay, in writing moment equation, and you kena make sure bila pilih origin yang ni, limit betul tak dengan origin tu, section betul tak relate to origin dengan limit yang kita dah set. Kalau you rasa tak comfortable for BC and CE, you still nak choose A as origin, you still nak choose D as origin, you just can continue, doesn't matter. Tapi kena careful dengan limit pula. Okay. So yang saya bagi contoh hari ni, when we set limit semua from 0. That is why kita dapat yang macam tadi lah. Okay. So retry. Okay, try. Check balik mana-mana equation. All this is the right equation. If all the moment equation are correct, so we should get the correct answer. Okay, the correct answer. Okay, so I think I have to stop now. So thank you for joining. Saya lupa saya nak set U future, terlupa nak set U future. Doesn't matter. Okay, so please watch recording. Ada banyak example video-video yang saya dah buat related to this topic. Jangan tengok hanya video-video SEM ni je. SEM selepas pun ada banyak saya buat. So boleh tengok untuk enhance your understanding. InsyaAllah, I believe kalau you betul-betul tengok, you try buat exercise, this one should be okay. Okay, so all exercises please put into your OneNote class notebook, upload, okay, and let me know. Okay, saya tunggu you submit. Kalau you tak submit anything, saya akan assign you question. So now I don't want to assign you any question, any formative assessment. I hope that you spend time, do exercise, complete all the tasks given in class. Yang ni tak completekan, put the solution into your class notebook. Let me know, tag me so that I can check for you. Kalau saya tak dapat langsung respond, saya yang akan assign to everyone. Okay, please. Okay, please continue. Previous session pun tak sempat habiskan. So just need to complete it. Okay, complete it. Okay, and then put into this so that I can check your level of understanding. Saya tak nak, saya takut saya cakap seorang ni. Okay, saya nak you buat exercise so that saya nak tengok you faham ke tak faham actually. Okay, so I think that's all for this session. Thank you very much. We close this session with Tasbih Kifarah and Surah Wa'as.